I will introduce a little bit of myself first, and then products and also applications. I have worked a lot of years with thermography, and I work today as a business development manager at Fluke Thermography. The Fluke is a company specialized, you can say, in instruments for the industry to measure all sorts of electrical quantities, and like digital multimeters, scope meters. We have field calibrations for the process industry. We have the usual electrical testers, also installation testers, clamp meters, etc. We have also a line with temperature measures about thermographic cameras and power quality analyzers. So what is thermal imaging? Thermal imaging is the science of seeing temperatures, of seeing heat patterns, using, of course, special electronic cameras, what we called thermal cameras. These cameras, instead of seeing the image like we have here to the left, the visual picture, they also see, or they see a thermal image. The difference between these two images is that the picture to the left, that we can see with our own eyes only, is a reflected image. The picture to the right is an conditions. So it's hot, if there is a change in the process, we will see it immediately because we are looking at it with a camera that works with light. So we will see this transformation, the changes, with the speed of light. What is new in thermal imaging? Thermal imaging has been available for the industry for the last 40 years. What is new today are first of all the availability. We have cameras that are just 1/10 of the price we paid for them only 10 years ago, and also new features that can help even people that are not so used to thermography to work with confidence with these products. So what we have today is a camera that we focus, and by pulling the trigger we capture the image. So it's very easy, very simple to use. This image is then stored on a digital memory, and you take the memory to the computer, and you can in the computer analyze the images and perform all the types of analysis, looking at all different temperatures, etc., that you want to do. So this image that is here is a thermal image. It's not just a simple image, because to make this image it was necessary to measure 20,000 different temperature points. So the base of the image is a measurement, and then we present the image. But sometimes these images can be a little bit difficult to understand. It's much easier to look at the visual image and understand what we are looking at, because that's what we are used to do. What Fluke has done, and what is also new in thermography, is we have combined these two images in a creative way to make it easier for the customer to see what he's looking at. So now we have the visual image here, and we add to this image the thermal image. So now we can see both, and we can very easily understand what we are looking at and what the object temperature is and what it's telling us. Now in this case what we are looking at is a floor heating, electrical floor floor heating. And in this case, what we can see, for instance, before we install, is that there are no hot spots that will lead, maybe 1 year after that, to an interruption. So we can control the quality of the installation before we finish the installation itself of the floor heating. Now, if we use this technique in facility maintenance, what is facility maintenance? What do we call facility maintenance? It's the maintenance of office, shopping centers, commercial buildings, hospitals, hotels, administration buildings, schools, etc. Places where we work, places where we spend 8, 10, 12 hours of our time. It's very important to have comfortable places to work, and that means that we have air conditioning, that means that we have places with good elevators, etc., etc., but that also costs energy, and that is what we are going to talk about, how to save energy costs. If we first look at the facility, we have always the building envelope itself, and it's important that the building envelope is in good conditions. Then we have the heating, ventilation, and air conditioning systems. And also, of course, these heating, ventilation, and air conditioning systems also need motors, but we also have motors and generators everywhere. As I mentioned before, there the elevator, but we have motors everywhere. We are going to look a little bit at the power quality. The quality of the power that we give to the equipment that we are using. When we buy a kilogram of tomatoes, it's easy to see that the quality is good or bad. When we buy power quality, I also have included in this presentation a part with solar panels, and that will, after the solar panels, finish our presentation. So, the application itself with thermography is to look at the envelope, to look at the roofs, to see if the insulation in the roofs is okay, to look at the walls, how they are constructed, if there are any problems, for instance, with insulation, looking at construction joints and connections, and we are using pipes, conduits, chimneys, etc. All these need to be checked. Door, window frames, window sills, they account for an enormous quantity of energy. Actually, the anticipated savings following the use of a thermal camera, identifying the problem, %. So let's say by saying 15, I am not anticipating too much. Roofs are of course one of the problems. It's where we can make the greatest savings, and especially if they are flat roofs, we can have problems with this type of insulation, and we can make spot repairs which are much more economical than just removing the roof and replacing it with a new one. For instance, in this case, this is a typical image of a roof. What we see here is a roof that we know, or where we know, or we suspected that there was bad insulation. By waiting for the sun to heat up the roof and making the inspections 3 or 4 hours after the sunset, with the camera we can identify the zones that are wet, because those zones, like in this case here, will retain the heat longer and will show up in the camera as hot zones, warm zones. So we can just then mark the zones and replace the damaged zone. By doing this, we save costs and energy. Of course, we can also control, as I said, for instance, the insulation in a house. In this case here you see the building envelope has parts with lower temperatures. There is a bed ceiling between the insulation on the roof and the insulation on the wall, and that causes, of course, problems. The problem here to the left is lighter than the one to the right. As you see in the right, the zone that has been already damaged is much larger. And in this case here, we have actually a 40% reduction of the insulation value on that zone. When we discover these defects, we know that these defects can cause a lot of problems. First of all, they are progressive, so they will just increase and the area that is damaged will just become larger. Secondly, they very often have sanitary problems because by being cold they become humid, and humidity means in many cases mold. So we have a problem of sanitation with costs for reconstruction that are very, very large. Air leakage is also something that can very easily be repaired, and we do not pay attention to it. And air leakage of, if we have a building that is heated through, for instance, a window, or if we have a building that is air conditioned going out from the building, can be very, very costly because we are heating this, and that is, as I said, very easy to normally repair. So let's look at the second type. Let's look at the air conditioning and ventilation systems. What we can do with the camera is to connections. The electrical connections can be very important and can cause problems. On the 18th of June, the building where the European Commission works in Brussels had a fire in the electrical connections of the air conditioned system. The consequences of this simple fire was that 500 people for 10 days had no place to work. The savings, what can we save here? Well, we are producing in the air conditioning or in the heating system, we are producing heat or cold air, and we are transporting it to the places of work with conducts. So the ductwork has to be with good condition. It has to be well insulated so that we are not losing energy on the way. And that's by doing that, looking at all the connections, looking at the insulation in the tubes, looking at the temperature at which the system, the air conditioning system, is delivering its air. If we can put down 2 degrees in temperature, we will save 5%. So look at this, for instance. We have on the left here the image of a ductwork, and as you can see, it's not well insulated. Not enough. We have to do it better. In this case, there is missing insulation. As I said, tubes are important, and you can see here the junctions in the tubes are not good, and in this case it's a newly made installation. So if we can see now with the camera see that the junctions are not good, and that will lead to problems that will later maybe have to be replaced completely. And as I said, electrical connections. I gave the example of the problem we had that was on the building where the European Commission is working, and that can be explained by a simple case like this. You can see here cables, and one of the cables has a temperature of 75 degrees. Well, 75 degrees is above the limit of the insulation of the cable. PVC cables have a limit. There is a risk of short circuit, and later on also maybe problems with the fire. The short circuit in itself can also cause other problems to other equipment, because, as you know, short circuit can create transients. So we can easily identify, see where we have the problem, and maybe it's a simple problem, maybe just a loose connector. Look at the temperatures even in the visual image, or if we want, see how the thermogram is made. The third way to save energy is by looking at motors and generators. We all know how important motors are. Motors are normally what consume most energy, electrical energy, in many facilities. About 70% of the energy in facilities goes to motors, and about 20% goes to lighting. So motors are very important. We have to look how they work, if they are working properly, if they are overloaded, if they need lubrication, etc. So we have to look at, and we can do that scanning with the thermal camera. We can look at the airflow, the intake of air to the motor, to the electrical imbalance that will make the motor become hotter, the bearings, the insulation in the motor, the lubrication, and of course as well the electrical connections. So what can we anticipate here? Well, first of all, we can anticipate a better efficiency of the motor, a longer life for the motor, and we should control and check the power quality that we feed to the motors. The power quality is very important. We give gasoline to a car, we give electrical energy to a motor. We don't give bad quality, or we know what happens if we give bad quality, bad gasoline to a car. The same will happen if we give bad quality of electrical energy to a motor. So that means that we have to analyze the power quality. The international norm, the EN norm, says that the power quality that is delivered by when we use the electrical energy in our plant, there are many equipment that require non-linear charges, and that will distort, transform the power quality. We also know that we have other problems like transients, short circuits, blackouts, etc., that will also affect very much the motors. So one of the problems with motors is the temperature. A temperature of a motor of a certain type is rated to a certain temperature. If we have a motor that is rated to more than it's rated for, we have lost 50% of the insulation time. The insulation life will be reduced by 50%. So it is important for us to control. Thermography in this case gives us a very good chance to check all motors frequently. One of the advantages of using thermography is that thermography is easy to use and it's very quick. We just scan the motors like we scan the motors with our own eyes, and we can see that the motor is not working properly. So we can do something about it. We can bring in insulation testers, we can bring in vibration analysis to see what the problem of the motor is. But it is important that we control the temperatures of the motors so that we can understand what the problems are. If we have 300 motors, instead of using other means that take time, we can use thermography and identify those 10% of the 300 motors that really show problems, that show temperatures, and concentrate our efforts of maintenance on those 30 motors. Look at this one, for instance. What we can see here is that there is a spot there showing an anomaly. Is okay. It tells us by looking at the shaft that there are no problems of bearings, because otherwise the shaft would be hot. The same is telling us as well that the alignment is correct, because the shaft would be hot as well. But the thermogram is telling us that the problem here is in the body of the motor, in one part of the body of the motor. And the most probable cause in this case is a problem in the windings of the stator. So the insulation in the stator should be verified. These problems can show very early, so that we can correct the problem before we have to do any repair on the motor itself. That is also another very important point with thermography. Temperature will show problems at its initial to see it, because there are guards around the motors, etc. and we have to take them away or replace those guards with net, with a mesh. So here, for instance, you see that there is a problem, and you see the problem is not alignment. The problem in this case is bearings. Next image, and you can see now we have a problem in the coupler, not on the motor, on the coupler. So we have identified where the heat comes from. This heat will, of course, after a while affect the motor itself, but we have to see what is the problem with the coupler. Maybe it's just a problem of lubrication or bearings, but something is making the coupler hotter, and this heat is going to be transmitted to the motor and eventually will also increase the temperature of the motor, destroy its insulation. Now we have a problem instead on the motor side, not on the coupler side. I was saying before that if we are going to do this type of inspections, we might have to use nets or meshes to allow us to see, but at the same time be in security. These are some examples. Of course, connections are also important in motors, and because the motor vibrates, these type of connections are more subject to become loose than in other places. So it is important that we control the connections of the motors. Sometimes it's difficult. In this case, to do it, we see that there is a problem, and the problem is quite big. And normally we will not see, because the cover will take away a lot of these this possibility to see the heat. So in a normal case I would have to take away the cover, and to do that I have to do that in security. If I have installed a mesh, a cover that is a mesh, I remove the first cover, I have the second cover that gives me security, electrical security, and I can make the inspection. An alternative is to install this type of windows. There are special windows. They are not glass, because normal glass does not allow the infrared to come through. It's not transparent to infrared, so it has to be a special crystal. So, but we can, they are available. Fluke has this type of IR windows that allow both visual inspection and thermal inspection. Indoor substations, the same problem. We can see through the net, through the mesh, but if we can't, we can use this type of windows. It's very practical because it makes the procedure, the security procedure in these cases, and especially when we are working with equipment in tension, which we should when we are looking with a thermal camera, then can be dangerous. We know that it can be dangerous. In this case, we are doing it in a secure way. Power quality. We talked a little bit about power quality, and we all know that power quality is very important. Fluke offers a full line of power quality tools that can help you reduce your power consumption, because you can look at the tops and you can make new contracts with your electricity provider, and can also help you identify problems like transients, blackouts, all the types of power quality problems that we will not talk about today, but that you probably know. What we mean by power quality? We know that a perfect power supply would be one that is always available, but there is not. There are blackouts. And also always within free sinus curve, like this one. A nice sinus curve with the correct difference between voltage and current in time. But there are deviations. Deviations from the perfect can be tolerated. I mentioned before that there is a norm that is telling us about that. But it can be tolerated, but it has also to do with applications. Normally, it's not the energy provider that has bad quality. It is ourselves with our equipment and all the non-linear charges that we require that change and distort the power quality that has been provided to us. Normally you say that 80% of the problems with power quality happen within the plant, not outside the plant. So if we have instead, for instance, this is the curve, the current required here by a computer. As you see, it's not a sinus curve. And what happens is that this curve will distort the original curve and create harmonics. It will create higher frequencies. So instead of just a sinus wave at 50 Hertz, we will have all these others. You can see here in the graph. You will see the first one at 50 Hertz. You will see the third one at 150. You will see the fifth one at 250 Hertz, and so on. Normally we have problems with the third one and the fifth one. the harmonics can also have an influence in the power factor. If we have just the normal fundamental 50 Hertz, we have the cosinus phi and the power factor the same. But when we introduce harmonics in this system, when we have equipment requiring the power factor. And the fifth harmonic, by the way, is very, very important for motors. I will come back to that. So now we have another situation with the cosinus phi, the new cosinus phi, different from the power factor, and we are also importing, let's say, we are using energy of bad quality, and we are paying also for it. You know that the power factor is very important for what you pay. The harmonics on the cables have something called the skin effect, and it's very important for the temperature of the cable. What is the skin effect? Well, the current travels through the conductor and it's using all the space, so to speak, so all the surface. But when we have harmonics, the current of 150, that it is not using all the conductor to flow, it's only using the skin. And the higher the frequency, the thinner the skin. So the effect on it is that the resistance on the conductor to the passage, to the flow of the third harmonic is much higher than to the flow of the fundamental. It's higher for the fifth harmonic and for the third harmonic, and that will heat up the conductor in an abnormal way. So for instance, if you have 1 ampere of harmonic of the third order, that is 150 Hertz, it will generate a heating that is 9 times higher than the same current at the fundamental frequency. So just imagine that you have 5% harmonics. 5% harmonics on the third. That means that you have a 20 amp system. 5% will be 1 amp. You have 1 amp, you have 3-phase systems. So you have 1 amp. That 1 amp will cause a heating of 9 amp of the fundamental. And because you are using a 3-phase system, these will add up in the neutron. Amps that you had from the fundamental. So now you have suddenly 47 amp. The cable is rated for 20. So the cable will heat and the insulation will be destroyed. And you have a problem. Maybe a short circuit, and following the short circuit maybe you have a transient that will destroy something else. Here, example, you can see a defect here, but you can see also an imbalance, maybe due to harmonics. You will hear the one that is because of overload or because of harmonics, and that gives a very homogeneous heating in all the cable. So you can see with thermography, you can see differences. Now here is an equipment, and transformers also suffer a lot from harmonics. In this case we have problems. One problem with harmonics and another problem with the circulation. That is, the oil in the transformer is not circulating properly, is clogged here. But harmonics in the transformers can reduce the lifetime of a transformer from 30 years to 7-8 years with enormous costs. Motors. I mentioned before that motors have a certain temperature, and each 10 degrees rise over the maximum rated temperature will reduce with 50% the life of a motor, due mostly to insulation failure. The fifth harmonic is one of the worst for motors, because if the motor rotates clockwise, the fifth harmonic wants the motor to rotate counterclockwise. So it's like a brake for the motor. So we are giving a power quality, we are giving power to the motor, and the motor is using the fundamental to move the motor, and the fifth harmonic like 25 amp of the fundamental, 25 times more, and that will create a lot of problems. Thermography can help us, because if, as I said, you have 300 motors, you can check, if you want, every week, maybe even every day, but you can check the temperature of the motors very easily, follow up the trend of the motor, and identify where you have the problems. You identify the motors that are having problems. When you see that the motor has a temperature, you look at it, you see that you need to make other analysis, maybe a vibration analysis, but certainly a power quality analysis. About steam, and steam is very important as well, and we can of course check the refractory, we can look at the leakages, we can look at the casing of the boiler itself. It's very easy to do that, and it's important to do that. You can, for instance, if you are looking and controlling continuously a boiler with a camera, you can plan your maintenance of the boiler by replacing those panels in the boiler that need to be replaced, because you will see those. You don't need to wait for the boiler to cool down, to send someone in to check the panels, to see what panels you need to replace. You can do that from the outside. At least 75%. So you will do savings in maintenance costs, but you can also anticipate savings in the energy by looking at the boilers, looking at the ducts, the tubes, etc. Because it costs a lot to make heat, you can save 10 to 20% of fuel input. I will talk a little bit also about another thing that is important for steam systems, and that is a trap. A trap is just a valve, like you see here, with a cold side and a hot side. Here we have one working trap. You see, this image tells us this trap is working properly. And the hot side, where the vapor has been cleaned, and I have only, so to speak, only vapor. I don't have the two phases, I hopefully have only one phase. But I can see it very easily. These small traps, steam traps, maybe are placed 5 meters away, I can, with the camera, from three, 4 times a year, with acoustic methods. But look at this trap here. It's a trap that has a cost. It's a trap in a school. A trap that has a cost of about 100 euro. Now it's 85 pounds, but it's about 100 euro. Then it becomes important. If we control the steam traps 3 times a year, that means that we control them every 4 months. And if we control them every 4 months, that it also means that for 2 months the steam trap maybe has not been working in average, and we do not know about it. So we can have a trap not working for 2 months without knowing it. That means 60 days. And 60 days can cause, now in this case, a loss of 6,000 or 7,000 euro. Now, there are many steam traps. Many companies have steam traps 50, 100, even 700. So, if you just think about how many steam traps, 10% of the steam traps can fail during a year, you can see how you can very easily pay for or justify the purchase of this type of instrument to check the steam trap. Why? Because with a thermal camera you can do it frequently. It's very easy to do it. You can do it every week, and by doing it more frequently you can reduce the time where the non-working steam trap is not working properly. Now here you can see the image that it's working. We have a difference in temperature. Here the temperatures out and in were the same, or almost the same. So it was not working, it was just a bypass. So it's something that it's very easy to do, and that can save up to 75% of the cost of the steam losses. In solar panels, thermography can be used to identify faulty cells, to identify faulty connections in the cell, between cells, and also to evaluate the loss of efficiency of the panel itself. You know that there is a cell, and the cell produces electrical energy when heated or when exposed to the sun. The efficiency of the panels, of course, depends on a number of factors like the solar load, the quality, the dirt on the panel, etc. But also, as I said, also on the quality of the panel, and that's what we are going to concentrate us on. Cells can be inspected very easily with an infrared camera when exposed to sunlight. We have to do the inspection when the cell is exposed to sunlight, and we can do that from the front or from the back. Here you can see a defective cell, 85 degrees. Here you can see a zone of cells that are not yet defective, but are running at a much lower efficiency. So this one has 6 months, this one has about 2 years. As you know, the hotter the cell is, the lower the voltage that it delivers. So temperature of the panel is important for the efficiency. And here you can see again those two examples I mentioned. See, you can see the cells, yeah, and you can see exactly what we don't have. We have here we would say a bad quality panel. Or we can just find that the panel is okay, but one cell is not working properly. Of course, that when one cell is not working properly, it's going to influence, and you can see it on the distribution here, it's going to influence the efficiency of all the other cells that are working around it. If you leave it there without taking it away, it will also make the other tomatoes become bad quicker. Panels are controlled with thermography according to the ESN norms that you have here. The normal working cell exposed to light has a working point, and it will deliver a certain voltage to a certain level of current. But when it gets hot, the point of work changes, and instead of giving us a voltage, it requires voltage. So it's actually consuming energy instead of giving energy. You can see you will see a panel now with a defect. I showed this image because it's actually easy, because we have to check the panels when exposed to sunlight. Is actually easy to control from the back of the panel, but if not possible, we can also control from the front. It's better for the operator, not for the camera. It's on the shadow side. We can also control, as I said, the cells itself, the protection, the diode box, or the internal connections between cells. So, thermography can also use to control the protection box, the driving motors, the inverters, etc. The last connections or bad connections, hotspots. By using thermography, we can reduce the fire risk with 50% in less than 2 years. And the electrical companies know about it. And also the insurance companies. So, what are costs we're talking about? That's enormous. 350 million euro was what the insurance companies paid because of fires in Sweden in 2003. 350 million euro. The country is only 10 million people, so if you talk about a country like France or UK that has 10 times this amount of people, or at least 5 times that amount of people, we are talking billions of euro every year for problems that can be reduced just on the fire. But as you know, as we talked about, by checking this, we can also make better maintenance, and we can avoid short circuits that normally cause a lot of problems. So, if you using this technology, thermography, and combine it with other technologies like power quality, you can find problems. You will find problems. You will solve problems faster. You will save money. With the minimal investment, we are talking really about a very small investment of a few thousand euro. You have a payback potential that is extremely large. And you can, if you're working with maintenance, you can always verify that the problem has really been solved. After you have done the repair, you can check again and see, okay, now it's okay. So, with this, I finish my presentation. I thank you so much, and I hope that you have some questions. Thank you. Sergio?
Yes, Vicente, thank you very much for your presentation. It was, yeah, from my point of view, indeed very clear. I am again impressed impressed by what you can achieve with thermography. I can see that we still have a few minutes to answer a few questions, but there ain't that many questions coming in. So we have one question from one of the attendees, and I invite all the attendees to still pose their questions. So if we don't have the time to answer them today, we'll have them answered by written and posted on the website. We'll share all that with you. So I'll read the question we have. It comes from Efstratos Psarianos. I'm sorry if I mispronounce your name. So you ask for motors. Could you explain why the fifth harmonic drives the motor in the opposite direction of the fundamental? So why does it act as a brake?
It's not only the fifth harmonic, but there's a couple of harmonics that do that, and that is because it has to do with the phase. So harmonics of a certain order have that capability. They create a magnetic field that is inverted to the order of the fundamental, and then makes the magnetic field turn the motor on the other way. So simple as that.
Okay, very good. So we have another question from Shankar. What is the accuracy of temperature measurement with thermal imaging?
Well, it's very interesting. You know, accuracy is not the most interesting part in this, because the accuracy, okay, we'll answer first the question. The accuracy is normally 2 degrees or 2%. That is general for thermal cameras. But if you are looking for high accuracy, then you should helps us identify problems. We have in Fluke instruments that cost 1/10 of the cost of the camera, and can measure temperature from a distance with the same technology, with accuracies of less than 1%. But they don't give an image. So I think they are less interesting in this context.
Yeah, so now we have a question again from Efstratios. The information concerning this. So I can add just a word before you answer, Vicent.
You can get all the information from the Fluke site, and I think it's the order of harmonics is the 5th, the 8th. I don't remember exactly the sequence. There is not a sequence like 5, the 5th, the 10th. There is another type of sequence, but it depends on exactly what I said before, how they create the magnetic field. But you can find this information on the Fluke website.
Very good. Thank you. We now have another question from Sean Watson. So we asked whether fire safety assessments have infrared surveys been incorporated into any fire safety standards. Are you aware of any of this?
Yes, you know, let's say that all the fire protection associations of Europe work with thermography. The statistics I've shown to you is from the Fire Protection Association of Sweden. And they also are, for instance, the Fire Association Protection of Sweden are the ones that afterwards can certify thermographers in Sweden. The same in France. You have planes. Well, there is an incorporation, so to speak. CNPP means Centre National Prévention, that is the same as Fire Protection Association of France. So yes, there are norms that are followed by the fire protection associations regarding temperatures, and they all normally recommend thermography.
Thank you. So we have now a note from Stefan Fassbinder. So he mentions that everyone out there does that. So download the power quality teaching toy, and this displays and explains how the harmonics work. So from the Leonardo Energy website you can download a number of guides and the power quality teaching toy that will take you further understanding harmonics. So now we have another question from Danilo Zulian. So it says, I'm working with the thermal camera for about 2 years. I have a problem if I'm working outdoor to inspection electrical lineas.
I have the background reflections.
Yes, so when he's looking at the overhead cables, he has a reflection from the sky that does not give him a lot of accuracy on measuring the cable, I imagine.
Well, the problem of reflections can be avoided by placing yourself in another place. If you can't, I mean, it's the same as a normal light reflection. By moving, you can avoid reflections. If you can't, if the reflections are, for instance, from the sun, then you should make the inspection during the evening or when the sun is not present. That will also take away the problem of the solar heating.
Okay. Very good. So we have now another question from Paresh Trivedi. So can we detect natural gas pipe leakage if this is underground?
If the pipes are underground?
Yes.
Yes, okay, depends on what normally, if it's oil or water. If it's water, it's quite is oil, you normally can also do that by doing the same as in the roof that I presented before in the roof. If you do the inspection after the sunset, the zones where there are oil will retain the heat longer. So you can see that if you are just looking at it with the right at the right time of the day.
Very good. So we now have another question from Arfat. It's really a great idea to think about energy conservation via maintenance actions of engineering systems. So could you please put some more light on this aspect? I wonder that he was asking about some case studies you have, so a factory that is actually using thermal cameras and actually reducing their energy bill overall, the factory and the equipment.
Well, we have thousands of customers, and I know that thousands of people are doing that, and they reduce their energy bills. I can remember one now, a customer. I cannot mention it, but it's a big company in Saudi Arabia, and I was talking to the maintenance manager, and he has reduced his steam costs by 30% by checking the ducts. But I mean, normally, if you are just doing better maintenance, you can really reduce costs.
Would you have some documentation on that?
If you go on the internet, also I can give you some examples. First of all, if you are interested in this, there is a site in English called www.action-eco. Let me just a moment. I will try to find the site.
We can share that afterwards with.
Okay, there is a site where you can, the site is, I can send you the link to this site where you can look at just cases. People put their cases there and are also invited to put their cases there so that they can exchange best practices. It's not a Fluke site, it's the company, the mother company of Fluke that has started this site. It's called Action-eco. actionecho.org.
Well, we can send it then afterwards.
It's very easy.
So we have a.
It's sorry, it's very easy. It's actionecho and in one word .org. But we can send it as well.
Very good. So we have another question then from Carlos Umali, and maybe this will make it the last one as we're running out of time. Does regular infrared survey help reduce insurance costs? So is an insurance company open to reduce your premium if you have good practices on checking up your equipment?
Yes, that's a very good question. That is the point. Yes, they do. You see, the insurance companies know that the fire reduction is by 50%. They can insurance companies have made this D19 and they specify what has to be done so that you can get the discount. But come in Norway, I know Storebrand does it, I know Allianz does it, I know AXA does it. So Norway, Belgium, France, there are countries already where the companies are doing it actively. They are requiring many times to their own customers to do thermographic inspections.
Very good. So I think I will still have one more question because I think it's an important topic and maybe not very familiar to general knowledge. So regarding the photovoltaic panels, you mentioned. So by the way, I think it's really interesting the way we can analyze it with a thermographic camera. But when you mentioned that cell is not working, what does that exactly mean? It means that the cell is not well connected to the overall infrastructure, or that the silicon crystals are not good quality, or what does it exactly mean?
Okay, I've shown different problems. The cell is not working. Can I show a picture here?
Yes,
I can go back.
Yeah.
So okay, let me see. Okay, the cell is not working. I have given examples of this, like in this case, as the temperature increases in the cell produces less and less voltage. And when it comes to 85 degrees, the point of work, the working point there, is requiring voltage instead. So when you see a cell that is hot, you can see, you look at the panel, sometimes the cell has only 60 degrees while the other cells have about 25, 30 degrees. So you have a cell that is working at 60 degrees. It's still producing energy, but it's producing less energy than it should. Then you have cells, you have seen some images, where the cell's temperature is 105 degrees. I showed one case like that. In this case, the cell is not producing any energy at all and is instead requiring a lot of energy to be heated up. So it's working like resistance. And that is because of the quality of the crystal. Because the cell works with a gap. There's an energy gap, okay? As the temperature increases, the gap is going to be reduced. When the gap is 0, 85 degrees, then the cell stops working. It's because of the nature of the semiconductor. It's a semiconductor type of work. It's just physics. Did I explain myself?
Yeah, that answers exactly my question. Yeah, perfectly. But it's actually impressive because many people think you invest in photovoltaic panels, a big farm, just put them there and let it work, and you have an investment that you'll have a return on your investment over a number of years. But actually, a small change in the temperature will dramatically decrease the efficiency. So your return may be multiplied for a number of years. So this is also an attention point.
Yes, very good.
Very good. So. we have the chance to collaborate again in the future. I would like to thank also all the attendees for joining us today. So again, I remind you that we'll post the recording of this presentation online, and you will all receive an email with the link to it. Yes, and that's all from my side. I hope you join us in the next in one of our next webinars. So have a nice rest of the day, everybody, and until next time. Bye bye.
Bye now. Thank you so much. Thank you to all the listeners.